All right, guys, nuclear chemistry, day 6. Here we go. I have the reference table and on the left to assist you. Aim, how do we determine half-lives? So here's a do not question. How many grams of a 16-gram sample of francium-220 will remain after 82.2 seconds? So hit the pause button and answer the question below. Okay, we're back. Here we go. So, they gave us over here 1 unit of mass and 1 unit of time. So what did we learn on the last video? That if you have 1 unit of mass and 1 unit of time, your answer must contain 2 units of time. Okay? So over here, we must look up the half-life of francium-220. So let's find it on table N over here. Here it is. The half-life says 27.4 seconds. So the total time they gave us was 82.2 seconds. Divide by 27.4 seconds. That gives us 3 half-lives. So once we determine the number of half-lives, guys, how many lines do we draw? Well, 3. 1, 2, 3 lines. And what's the mass they started us off at? 16. Right? 16 grams. So what's half of 16 grams? 8. What's half of 8 grams? 4. What's half of 4 grams? 2 grams is our final answer. By the way, check out this little cool clip of Ice Age on the bottom here. That's always funny. I love that movie. All right, let's move on to today's work. All right, here's table N again. Okay, look, have your tables ready when you do this. Here we go. This is the 8th thing we learn in this chapter. Half-lives of mass. If 2 units of mass are present, begin having the larger mass object until you reach a mass of a smaller object. This will tell you the number of half-lives. So before, guys, what we did? When it was 2 units of time, we divide the large number over the small number, right? This time, if you see a question that says 2 units of mass, we're not going to do that. We're going to simply do what I just said. Look at the larger mass and keep dividing by 2 till you reach the lower mass. So here's the question at hand over here, okay? If 160 milligrams of a radioactive element decays to 10 milligrams in 30 minutes, what is the element's half-life? So look at the question. Are there 2 units of mass or 2 units of time given here? Well, there's 160 milligrams here and 10 milligrams there. Grams and milligrams, we learned, are units of mass. So we have 160 milligrams. We're going to simply keep dividing it until we reach that number 10. What's half of 160? Well, 80. What's half of 80? 40. What's half of 40? 20. What's half of 20? 10 milligrams. Now count the lines, everybody. We have 1, 2, 3, 4 lines. So how many half-lives then to go? Well, I underwent 4 half-lives. Right? So it says, what is the element's half-life in minutes? Well, look at the question. How many minutes it took? 30 minutes. You simply take that and divide by the number of half-lives. Well, take out your calculator, guys. What's 30 divided by 4? Well, that's going to give me 7.5 minutes. Okay. Here we go. Let's do the next one here. Now, I'd like you to actually hit the pause button and try it yourself. All right? Here we go. Okay, I'm back. Here we go. So, in 6.2 hours, a 100-gram sample of AG112 decays to 25 grams. What is the half-life of AG112? Well, what did they give us here, guys? They gave us 100 grams and 25 grams. Is that 2 units of mass or 2 units of time? Well, that's right. It's 2 units of mass. So, where we learn? We say you start the larger mass object. And you're going to keep halving it until you reach the lower one. Start at 100, end up at 25. What's half of 100? Well, 50. What's half of 50? 25. How many lines passed? 2. So that tells you the number of half-lives. It tells you since I went 2 lines, I went 2 half-lives. How much time passed, by the way? Well, 6.2 hours. So you simply take that number, there's your numerator again, over the number of half-lives. That gives me 3.1 hours per half-life. That means every 3.1 hours, half the mass is gone. Okay. That's why I went from 100 to 50. After another half-life, 3.1 hours, went to 25. Let's move on. Oh, I'm sorry. Let's go back 1 second. Oh, over here. Guys, look at the bottom over here. All right. The bottom says over here, original sample. Whenever you see a question that says, how much was in the original sample, we're not going to divide by 2 now or half it. We're going to multiply the answer by 2. All right. Here we go. Okay. Let's read the question together, okay? After 74.16 hours, a 1 gram sample remains unchanged sample K42. How much K42 was in the original sample? So remember, guys, when the question ends, it says how much was in the original sample. We're not going to divide by 2 or half it. We're going to multiply by 2. So, first of all, let's go over here. We have 74.16 hours. We have 1 gram. So the only gave is 1 unit of time and 1 unit of mass. We learned yesterday, and also in doing that question, that if you have 1 unit of time and 1 unit of mass, well, I don't see 2 units of mass, do you? No. This is just the isotope. That's not the mass. Okay, that's the mass of the isotope. It has nothing to do with the question. So if you have 1 unit of mass and 1 unit of time, that means you have to look up the other unit of time. So the total time is 74.16 hours. So look up the mass of K42. There it is, 12.36 hours. So to take that number, simply divide by 12.36 hours. So you take out your little calculator, divide them. We're going to get 6 half-lives. Now, that means how many lines we draw. Well, we're going to draw how many lines? 6. 1, 2, 3, 4, 5, 6. 6 half-lives, guys, all right? So 6 lines. Well, what's the mass we start at? Well, we start at 1 gram. That is the mass we start at. It says, what was the original? So that means we're going to multiply by 2. What's 1 times 2? 2 times 2. 4 times 2, 8 times 2, 16 times 2, 32 times 2, 64 grams was in the original sample. Okay, let's proceed. Another type of question you'll see, most likely on your Regents or any other exams that you take, is fraction remaining question. It's a very popular question, guys. All right. So let's read what it says here. If a question states, what is the fraction remaining? You start with the number, what does that say? 1. Then continue halving that until the answer is desired. So let's look at the question below. A 42-gram sample is a half-life of 1.23 seconds. What fraction sample remains after 4.92 seconds? Well, what did they give us here, guys? 2 units of mass and 2 units of time. That's right, 2 units of time. 4.92 seconds, 1.23 seconds. So what do? When we say 2 units of time, guys, we're going to simply divide. A larger number goes on top over the small number. That'll give us the number of half-lives. In this case, there are 4 half-lives. So how many lines we draw? Well, we're going to draw 4 lines. 1, 2, 3, 4. What's the mass they started us at, guys? 42 grams. So 42. Okay. I'm sorry. It says fraction main, right? My apologies. Fraction main means we start what number here? 1. So what's half of 1? Well, what's 1/2? What's half of 1/2? Well, 1/4. All you're doing, guys, is simply multiplying denominator by 2. What's half of 1/4? 1/8. What's half of 1/8? 1/16 is our final answer. All right. Let's do one more question on that. You can press pause now and answer the question right now. All right, and we're back. Here we go. It says over here, sample of 80 grams has a half-life of 10 years. What fraction of the sample will remain after 40 years? Again, guys, what do we notice over here? Well, it says fraction remaining, so that's important. I see 10 years, right? 10 years. I see 40 years. Is that 2 units of mass or 2 units of time? Well, it's 2 units of time. We take the larger number and simply divide it. What's 40 over 10? Well, it's going to give me 4 half-lives. So how many lines we draw, guys? 4. 1, 2, 3, 4. Fraction. What number we start on? We see the word fraction we just said. That's right. 1. Start with 1. What's half of 1? Half. What's half of half? 1/4. What's half of 1/4? 1/8. What's half an 1/8? 1/16. Just so happy the answer has to be 1/16 again. I've seen the answer is 1/64, where you have 6 half-lives. So don't just think it's always going to be 1/16. All right, that's it for today.